Processing bitmaps. Before creating our job file and setting the laser parameters, we should first consider the job at hand, such as the size of the image to be produced, the reaction of the material to the laser, and other factors such as any commercial limitations with regard to processing times. It is possible to generate a smaller engraved spot for materials that are sensitive to the laser, for example anodized aluminium. For these types of material, a higher image and mechanical resolution can be used. Note that using a lens with a shorter focal length will produce an engraved image with a higher resolution, but this will require a longer processing time. Generally speaking, the lens with a 4-inch focal length is not suitable for marking bitmap images. A lens with a 2.5-inch focal length will produce a coarse engraved effect in the shortest possible process time, but for most jobs we'd recommend using the 2-inch or the 1.5-inch focal length lens. Some materials, such as wood for example, require a higher laser power in order to achieve any contrast. As a result, the actual engraved spot will be large, so these types of material can actually look better if the image is engraved at a lower resolution. The resulting quality of a laser engraving relies heavily on the quality of the image file itself. For best results, use an original image that has a resolution of at least 300 dpi and one that shows good tone and contrast. For best results, our software should be used to position the image only. We recommend that adjustments to the image size and orientation should be made using a dedicated image editing software such as Corel Photo Paint. Then import the image to our software at the correct size and orientation. Only use images that are saved as grayscale, 8-bit or halftone, 1-bit. Do not use color images. Import and position your image file. Select the image, go to the handle menu, then select bitmap handle, or use the shortcut in the system bar and the bitmap handle will open. If required, adjustments can be made to the brightness and contrast. In this example, we are engraving on clear acrylic material. The laser will mark the parts of the image that are black. Cast acrylic laser engraves with a frosted white effect, which is the exact opposite of what's shown on the computer screen. Therefore, we will have to invert the image to swap the white values for black. To see the result, click on Apply to View. Next, select Dither. Here we can apply different types of halftone effect. A halftone is a type of dot pattern applied to an image to represent darker or lighter shades as a series of black and white pixels. Where a black pixel exists, the laser will fire. Where a white pixel exists, the laser will not fire. Set output resolution. This is a value that will determine the image resolution according to the halftone effect that is chosen. A higher value will produce a greater number of smaller pixels, a higher resolution, and a smaller value will produce a smaller number of larger pixels, a lower resolution. This value should be considered carefully according to the material type and the lens being used. Ultimately, we need to consider how small we can reproduce an engraved spot on the material and match the set output resolution value to that. For most applications that require a high quality engraving, the set output resolution values will be 70 for the 2.5-inch lens, 97 for the 2-inch lens, and 159 for the 1.5-inch lens. Net Graphic will create a mesh patterned dot effect. Dot Graphic creates tiny dots which are concentrated in the darker areas, less concentrated in the lighter shades, and none in the white areas. Dot Graphic is the recommended filter for the majority of laser engraved images. Black and white makes a more solid black and solid white image with no midtones. In this tutorial, we are using Dot Graphic. After altering the values, click on the Apply to Source button and close the bitmap handle window. Check that you have the correct lens fitted to the machine according to the values you have set. Change the lens to match the values if necessary. Apply your engraving parameter settings. Note that using a lower laser power and a slower motion system speed is likely to produce a better quality result, especially on sensitive materials such as cast acrylic. Remember that when using a laser with a DC source, the lowest possible power setting is 30%, and that when using a laser with an RF source, the lowest possible power setting is 10%. Set the interval value according to the optical characteristics of the lens being used. For more details about plano-convex lens specification, please refer to our separate support video on this subject. Generally speaking, for a lens of 2.5 inch focal length, the interval value should be 0.15mm. For a lens of 2 inch focal length, it should be 0.1mm, and for a lens of 1.5 inch focal length, it should be 0.05mm. Using values lower than these is likely to produce too much of a spot overlap, which will potentially over-engrave the material and deteriorate the final result, as well as significantly extend the process time. Using values higher than these will reduce the image resolution as well as the processing time. Load the material to the machine and focus the laser. The job is ready for processing. Note that material flatness and the accuracy with focusing the laser are key factors to producing a good quality engraved result.